So here is given complex numbers associated with the vertices ABC of a triangle ABC, and the complex numbers are e to the power I theta, omega, and omega bar. Okay, omega bar and omega are complex cube roots of unity. You know that omega bar is nothing but omega square, and cos theta is greater than real part of omega. Then we have to find the complex number of the point where the angle bisector of A meets the circumcircle of the triangle. Okay. Now we can understand here that all of these complex numbers here given are unimodular. That is, their modulus is 1. They are all unimodular. Okay. So we can put them on a circle in the coordinate axis. Okay, we can put them on a circle. Right, you know where omega and omega bar will lie. That is very clear. That was very clear to you. Making an angle of 2 pi by 3 here, and this making an angle of 2 pi by 3 with that. So this, if you take this as omega, this vertically below will be omega bar. Okay. Now they're all at unit distance from the origin. So let us take the point e to I theta somewhere here. Okay. So if you complete this triangle, it look like this, something like this, right? And the complex number of the point where it meets it, if we try and draw that, I will draw the picture a bit and then explain. Now this is, say, angle A. What is here? A, this is B, and this is C. So we can say that these two angles are equal and they are A by 2, all of them, right? Also, if you notice that since the angles are equal, supposing we name this as the point D here, this should be the point, this should be the Z, the complex number we need to find out. Why? Because arc BD is equal to arc BC, right? That can only happen if this is angle A by 2 and this also is angle A by 2, right? So Z has to be on the circle and it also has to meet the x-axis to make this possible. Arc BD is equal to arc BC. So equal arcs obtain equal angles. Now, if you draw two more lines here, say joining this to the origin, okay. So what do you expect? This properties of a circle. This angle should be A here, and this angle should also be A here, because it is double what is subtended at the circumference. So we notice that this angle is A, so omega, relation to omega and Z should clearly be Z equal to omega into e to the power IA using Coni's theorem, right? Okay, this is one. Again, you notice that omega bar has the same relation with Z, and that is So from 1 and 2, what do we get? We can say that z square will be omega bar, right? And here in this case, what is omega bar? It's nothing but omega cube, and that is 1. So from here, we get z should be equal to plus minus 1, right? Now, one fact I missed talking about is this angle given here. Why did I take a here? I could have taken a here on this side also. But here it's given that cos theta is greater than the real part of omega. Now, what is the real part of omega? It is minus half. So cos theta will be greater than minus half. So that makes it cos theta will be greater than cos 2 pi by 3. 2 pi by 3, right? And what does that give us? That gives us that theta is less than 2 pi by 3. So if this angle itself is 2 pi by 3 here, as you notice, so e to the power I theta should lie somewhere on this half here. So we've taken it here at A. Okay. So cos theta greater than the real part of omega gives us that clue. So since the diagram looks like this, so z has to lie here. So z cannot be plus 1. Therefore, z has to be minus 1. And what is minus 1, by the way? It is omega plus omega square, which is omega plus omega bar. The correct answer is choice D. Got it?